Number 13. The ratio of the side lengths of rectangle A to rectangle B is 4 to 9. So let's stop right there just a minute and break this down into real life language. A ratio is a comparison. So the comparison of the side lengths of A to B is 4 to 9. The thing you have to realize here is that this is not a dimension. It's not 4 inches or 9 inches or 4 feet or 9 feet. This is a comparison. It's a scale factor. So 4 to 9 is not an actual measurement. It's a scale factor. It's what, about 44%? 4 to 9, if you did that as a decimal. Let me just do it. It's 44 or 45, maybe 45. It's right in the middle, but it rounds to 44. So approximately 44%. So if I wanted to enlarge, say, photograph A to photograph B, I would enlarge it at 44%. I could also reduce it by 44% and keep the proportions of the two photographs. So realize that 4 to 9 is not a dimension. It's a scale. Okay, the next thing we have to do is think about what area is with a rectangle. And we know that to find an area of any rectangle, you multiply the length of the rectangle times the width of the rectangle. Now, if I knew that 4 and 9 were actual dimensions, I could go ahead and multiply it and be done. But they're not dimensions. They're scale factors for the sides of this rectangle. So I need to think through this a little bit more. So I want to take the area of rectangle A, and I want to compare that to the area of rectangle B. So I'm setting up this problem using a ratio because that's how this scale was presented to me. And I know that to find an area, I have to multiply length and width. So if I just had one rectangle, I would just put it in like this, length and width. But I don't. I have two rectangles. So I'm going to use a little bit of algebra notation to say the length of rectangle A times the width of rectangle A is the area of rectangle A. And then I'm going to say the length of rectangle B times the width of rectangle B would equal the area of rectangle B. So I haven't changed anything. I'm just writing this in different notations. And you can stop the video and let that really sink in if you need to. I'm just comparing two areas at this point. So then I'm going to go ahead and split the dimensions so that I have the two lengths being compared. And I'm going to put that in parentheses so I can separate it from the two widths being compared. Okay, so all I've done there is to split that area ratio apart so that I'm comparing the lengths of both. So here's the lengths, and here are the widths. I'm still doing length times width for area. I'm just breaking these factors up. And here's the million-dollar question. What is the scale factor Remember, a factor is just something that gets multiplied for this relationship. And hopefully it's in your mind. They're related at a 4 to 9 relationship. So the lengths are related that way, and the widths are related that way. And now I have something I can work with. 4 times 4 is 16, and 9 times 9 is 81. Again, these are scale factors. Anything to do with this relationship is related at 4 to 9. So once you plug that in there, you can multiply to get your answer of 16 to 81, which corresponds to D, 16 to 81.